Today we're going to learn about negative exponents. Any non-zero real number raised to a negative power is a negative exponent. A negative exponent, for example, is something like x to the negative first. The exponent here is negative, as the negative one is a negative number. Now there's two ways we can simplify expressions that have negative exponents. The first is the quotient of powers rule, in which we know that x squared over x to the third is equal to x to the second minus the third, which is going to be equal to x to the negative first. In order for an expression to be simplified, we can't have the negative exponent. And there's something called the negative exponent property, in which x to the negative first is going to be equal to 1 over x to the first. When you have a negative exponent, like x to the negative 2, you can remove the negative exponent by simply putting it over 1. So this is actually our solution for the first problem. Now there's another method you can use to simplify this expression called the definition of powers. So we know x squared is equal to x times x, and x third is equal to x times x times x. We know x over x is equal to 1, so for every x in the numerator and denominator, we can cancel them out. So eventually, we're going to get x in the denominator by itself, which you can simplify to 1 over x. So how do we solve the second problem here? Well, we see that the variable a is only in the numerator, so that's going to stay the same. And then we have a b in the numerator and denominator. So we can actually split this expression into a to the negative fifth over 1 times b to the fourth over b to the negative second. This is going to be equal to, using the quotient of powers rule, b to the fourth minus negative 2. So we can't have a as a negative exponent. Again, we're going to use the negative exponent property, like right here, as a to the negative fifth is equal to 1 over a to the fifth. And then we have b to the sixth. So our solution is going to be b to the sixth over a to the fifth. Lastly, we have this big expression here. So let's first split up this expression into several components based on the variables. Now we can easily see the distribution of the variables. 3 over 6 is equal to 1/2. So that's going to be 1/2. X to the third divided by x to the negative fourth. We know that's equivalent to x to the third minus negative 4, which is equal to x to the seventh. So x to the seventh on the numerator, we know that y to the fifth over y to the seventh is equal to y to the fifth over y to the fifth times 1 over y to the second. This becomes 1, so we're just going to have y to the second on the denominator. And finally, we have z to the negative 6 over z to the negative third. So that's going to be z to the negative 6 minus negative 3, which is going to be equal to z to the negative third. Now we know if we have z over 3 in the numerator, then we have a negative exponent. So we need to flip the numerator and denominator to get rid of the negative 3. So it's going to be 1 over z to the third. If we add up all these numbers together, we're going to have x to the seventh over 2 times y to the second times z to the third. So that's going to be our simplified expression.